So this is our RL series circuit where R and L both are in series. So across this R there is a voltage drop VR. Across this L there is a voltage drop VL. Okay. So this is the input voltage. We have applied Vm sine of omega t. Now we have to draw the phasor diagram. Because there is a resistor and the voltage and current are in the same phase, therefore we have represented this. And in case inductor, voltage leads the current with the angle of 90 degree. That's why we have represented real voltage in this y-axis. Now we have to draw the resultant vector across these VR and VL. And while drawing the resultant, we made a right angle triangle, and with the help of Pythagoras theorem we have to find out this angle. Okay, and we have to find out the voltage and current for this RL series circuit. So using Pythagoras theorem, h square is equal to p square plus b square, we have to put the values for voltages across perpendicular or the base or hypotenuse. Okay, so while solving this equation, we find out that our voltage is V is equal to I upon Z and current is equal to V upon Z. Okay, after that we have to calculate the phase angle. So phase angle can be calculated with the help of this tan of phi. So tan theta is equal to P upon V. P is the perpendicular, B is the base. We have to put the values across perpendicular or base. Okay, so as we can see in this, there is the across perpendicular the value is BL, across base value is B. So we have to put these values in these equations, and we have to solve this and find out the phase angle phi is equal to tan inverse of XL upon R. Okay. After that, we have to find out the power factor. So power factor can be find out with the help of cos of phi. So cos of phi can be represented by base upon hypotenuse. Okay. So across base we have voltage BR. Across H we have voltage B. So we have to put the values for BR and B, and this is our power factor R upon Z. Okay. In RC series circuit, R and C are connected in series with the input supply. This is the input supply Vm sine of omega t. Across this R there is a voltage drop VR, and across this C there is a voltage drop VC. So how to represent this? To IR, so I into across XC. Okay, across L there is a XL. Okay. So across this R, voltage drop is BR. BR is, how you can represent this BR? V is equal to I into R. Okay. So now we have to draw the phasor diagram. So as we have seen that resistor, in the resistor there is a no phase difference. Voltage and current are in the same phase. That's why we have represented this VR in x-axis. Whereas this capacitor has voltage and current phase difference. There is a 90-degree phase difference between voltage and current. In this case, in the capacitor, the voltage lags with the current the angle of 90 degree. That's why we have taken this VC, the downward position. Okay, so this voltage is lagging from current with the angle of 90 degree. Clear? Any doubt till now? So we have drawn this phasor diagram, and with the help of Pythagoras theorem we have to put all the values and find out the value for voltage and current. Okay, so in the next slide we have calculated all the values for voltage and current to B upon Z, where Z is R square plus X square. Okay, so this is the equation for the current, and you can derive this equation for the voltage also. V is equal to I into Z. Okay, now we have to calculate phase angle, same as previous, R, and the power factor cos of phi same as previous. So cos of phi is equal to R upon inductor and capacitor, all are connected in series. Okay. Now there are three cases. The first case is that C is greater than L, and third case is L is equal to C. Okay, so we can consider these three cases in our this derivation or derivation. We have considered that VL is greater than DC. Okay, so if we consider this this L is greater than C, then the voltage across the L also increases. Okay, if we consider C is greater, so VC is also greater than VL. Okay, so in the second case, we have to draw the result in downward direction because this VC is greater. In the second case, we can derive the expression and find out the value of current. Okay, so we have to put the values across BR, BL, and BC, and we have to solve this derivation and find the value of a current. Okay, this is the quick revision for the RLC circuit. So phasor angle can be calculated with the help of tan of phi, and we have to put the values in these P and B, and the values can be solved using this derivation, and we have find out that the phase angle tan is equal to tan inverse of XL minus X R, whereas the power factor cos of phi is represented with the base upon hypotenuse, and we have to put these values right here, and the power factor is R upon Z. Okay,